Hey everyone, today we're going to be covering section 8.4. Let's get into it. So 8.4 is on scale factor and area. So let's do a quick recap on scale factor. Scale factor was the amount that a measurement will change when you go from the original to the diagram. So whether it's an enlargement or a reduction, what you would do is you could take one of the measurements from the scale diagram and divide it by its corresponding measurement on the actual object. So the idea is, if let's say you had something that was 4 centimeters long and then you made a diagram out of it and now it is 2 centimeters long, well, you would have 2 divided by 4, so you have a scale factor of half, and we know that's a reduction. You'll often sometimes see scale written horizontally, so scale is sometimes written horizontally like so, with the diagram measurement on the left, and then the actual measurement on the real life object on the right. We can actually use the scale factor to find out the new measurement on our diagram by simply multiplying the actual measurement. So the actual measurement multiplied by the scale factor is how we would get our diagram measurement. Okay, so if our scale factor is 2, that means we plan on doubling everything. We would take our measurement, multiply by 2. That's going to be the new measurement on our diagram. If we plan on tripling everything, our scale factor is 3, so all of our measurements get multiplied by 3 to get our new measurements, and so on. Now, to get a better understanding of how the scale factor affects area, we're actually going to take a look at an example. So suppose we had a picture which was 5 centimeters long and 3 centimeters wide. Now, this picture has an area of, well, you guessed it, 15 square centimeters. You just take 5 times 3, length times width. Easy peasy. Now the question is, if the length and width are increased by a scale factor of 2, what is the area of this new scale diagram? Now you look at this and you think, you're going to double the length and double the width. You might expect the area to get doubled as well, right? Well, let's see. Let's see what happens. So here's our original object. It is 5 centimeters long, 3 centimeters wide, and the area is 5 times 3, which is 15 squared centimeters. So that's our area. All right, let's take a look at the new one, the new scale diagram. So in this one, we're using a scale factor of 2 to enlarge the measurements. So the length goes from 5 centimeters multiplied by the scale factor of 2. So now it is 10 centimeters long. Our width, which was 3 centimeters, gets multiplied by our scale factor of 2. So 3 times 2 is 6. So this new diagram has a width of 6 centimeters. And let's take a look at the area. Well, the area is still length times width. So that's 10 times 6. But that gives me an area of 60 square centimeters. That's not double. It's actually quadruple. It's 4 times the original area. So if we were to look at the scale factor, okay, this is how much our linear measurements are changing by. But a scale factor of 2, our area, so the ratio of our diagram area compared to the actual or the original area, in this case worked out to be 4. Okay, so a scale factor 2 gives me an area change of 4 times. Okay, let's try something else. Let's see what happens what if our scale factor was 3? What if we decide to triple all the measurements? Let's see what happens there. So suppose we used a scale factor of 3 instead. What is the area of the new scale diagram? Okay, so we had 5 centimeters by 3 centimeters. We're going to enlarge everything by scale factor of 3, which means I'm tripling all the measurements. My length gets multiplied by 3, so it becomes 15 centimeters. My width gets multiplied by 3, so that becomes 9 centimeters. And so now if I compare the area of my original is still 15 square centimeters. The area of my new diagram is 15 times 9, 135. Huh. That's a lot more than 15. In fact, let's take our diagram area of 135. Let's divide it by the original area of 15, and let's see how much it changed by a factor of 9. This is 9 times the original area. So when we used a scale factor of 3, our area, so our diagram area versus the actual area, became 9. So 3 times the length and width gives us 9 times the area. Hopefully you can kind of see what's happening here. The change in the area is related to the scale factor, but it's not the same. It's actually the scale factor if you were to square it. So 2 squared gives you 4. 3 squared gives you 9. If we had a scale factor of 5, our area would increase by 25 times. And so let's put that into writing. So when an object is enlarged or reduced by a scale factor of, and we'll just use a variable here, k, and k just represents the scale factor. It could be a 2, could be a 3, whatever it is. So when an object is enlarged by or reduced by a scale factor of k, the area of the object is enlarged or reduced by a factor of not k, but k squared. If you had a scale factor of 2, the area would have a change by a factor of 4, right? 2 squared. If you had an enlargement by a scale factor of 10, then the area would change by a factor of 10 squared, which is 100. And so that's what's happening here. Let's take a look at an example and see this in action. So a painting has an area of 280 square centimeters. If a scaled diagram is made with a scale factor of 1.5, what will the area of this diagram be? We are given the actual area of this painting, right? The original area. So the actual area is 280 square centimeters. Okay. They haven't told us what the length and the width are, but they do plan on using a scale factor of 1.5 to enlarge the length and the width. So we know that the scale factor, which is our K, right? If we're going to go by what we have here. Okay. So our K is equal to 1.5. Now, we know that the new area is going to be enlarged by a factor of whatever the scale factor is squared. Diagram area is equal to the actual area times K squared, right? We take our scale factor, square it, and then that's how much we can multiply the original area by to find out what our new area is. So our original area was 280. Our K is 1.5, which we're going to square it because we want to find out the new area. 1.5 squared is 2.25. So this is 280 times 2.25. So let's multiply that out. Times 280. So 630 squared centimeters is the area of the scale diagram. All right. So if you're given the scale factor, you're given the little multiplier for the length and the width and those measurements, you can now use that to figure out what the new area is by taking the old area and multiplying it by your scale factor, your K, after it's been squared. One last example, I'm going to show you how we can work with something where we kind of have to work backwards, and then that's it for notes for today. So in this final example, a mural is to be painted on a wall. The area of the mural will be 1/4 the area of the wall. So it's not saying that the length and the width are going to be a quarter. It's saying the area of the mural will be 1/4 compared to the area of the wall. If the wall is 20 feet tall, how tall will the mural be? In the previous question, they gave you the old area and they gave you the scale factor, okay, to find out the new area. In this case, they're giving you the old measurement, right, on the original, giving you the K squared, right, that area factor, and then they want you to use that to work backwards to figure out what the measurements will be, what the height of this mural will be. Okay, so let's kind of summarize what we're given here. 20 feet is the actual height, right? So the actual height is 20 feet, right? If we were to consider this mural to be the diagram, our actual height is the height of the wall. It's 20 feet, okay? This 1/4, that's not your scale factor. That's not K. This is the change in the area. So this is actually our K squared. K squared is 1/4, right? They expect you to take the original area, multiply it by 1/4 to give you the new area, okay? But if we're going to make changes and try to calculate what the height of our diagram is, we don't want K squared. We want K, because that's what we use when we change our measurements. We use the original scale factor. Well, if I know K squared is 1/4, then to figure out what K is, I need to undo that square. Well, we've done this before. We've done it with a number of things, including the Pythagorean theorem, including when you were working with the cosine law. This here calls for the square root. So I need to take the square root of 1/4. Okay? Square root of k squared is k. The square root of a quarter is half. So k is half. So that means I can now calculate what my diagram height is going to be. My diagram measurement is going to be equal to the original measurement times our scale factor, which is k. So actual measurement is 20 feet. K, we now know, is 1/2, so half. So that means that this mural, this diagram, will have a height of 20 times half, 10 feet. Okay, so just make sure you read the question carefully. Find out if they're giving you the scale factor, which is what they use to adjust linear measurements like length, width, height, those singular measurements. Or they might be giving you k squared, which is the factor for the area. How much is the area going to be affected by? Not the length, width, and height, but the area. Okay, and so using that information, you can then determine whether you need to make any modifications to your scale factor or area factor. All right, let's give you a couple questions to work on. So on page 487, we're going to do numbers 1 to 3 and 6 and 7. As always, the answers are in the back of the book. If you have any questions, you can always hit me up on Teams by messaging me and using the @ symbol. So you can say @EdChan, and then you'll get a little like suggestion or a little autocomplete. So you can click on that, and that way any message you type out, I get a notification of that immediately. And so I can hop on to give you a hand. You can also alternatively just email me, and I'm more than happy to hop on to Teams or Zoom or whatever you need to assist you. All right, that's it for today. Try out those questions, and if you need any assistance, let me know. Bye.